Alright, so I found a pack of 80 LEDs with more than 80 resistors on Amazon for about $5. And what I thought I'd do is solder them all to a piece of perf board and go from there. Alright, so I think we are going to open them up now. Okay. So, here's the thing. It gives the voltage and the brightness. 8 colors actually. Okay, so I have all these LEDs spread out, and this is actually really cool. They marked all the bags with the colors of LEDs, so like yellow, green, and then here are the more than 200 or more than 80 200 milliohm resistors. This is really nice. Alright, let's do some calculations. So what I want to do is I want to take a 9-volt battery, connect the positive lead to a resistor, and then have 2 LEDs in series, and then connect it back to the 9-volt battery. So what resistance does this need to be? If we use Ohm's law, where voltage, or V is voltage, I is current, and R is the resistance. I know from this little card that they gave me that each LED needs around 3 volts, so 3 volts, 3 volts, 3 volts plus 3 volts equals 6 volts. So the voltage drop across these 2 LEDs will be 6 volts, which means that if we use a 9-volt battery, we'll have, in a way, 3 volts left over, because 9 minus 6 equals 3. So that means that our voltage is 3. Our current, I know from this card, each diode needs 24 milliamps. So our current is 0.024 mA, should probably label these, and then R, because we don't know this variable yet. And the reason that instead of doubling the current needed, we only need to use the current that one LED takes, because all the current that goes into this LED, which is 24 milliamps, will also have to go through this LED. So each of these LEDs will have to get 24 milliamps. If they were in parallel, however, that wouldn't be the case, and the voltage calculation would be different, and so would the milliamps. We'd have 0.048 milliamps instead of 24, and we'd have 6 volts left over instead of 3. But instead everything's in series, so that makes the calculation the way it is. So if we solve for 3 volts, we can go 3 divided by 0.024. Alright, 125 equals R. So that means we have to have a 125 ohm resistor, and to calculate the wattage of the resistor, which is these are a quarter watt, and the wattage of the resistor is just how many volts and amps can be passed through the resistor safely without it heating up or burning up. So what we'll do to calculate that is take the voltage that's going to be passing through it, which is 3 volts, because these are going to slow it down, so we'll have 3 volts left over, like I said. So 3 volts times 0.024 milliamps, because that's how many amps are going to be going through. That's how many amps this resistor is going to be letting through the circuit. So 3 times 0.024 is 0.072 watts. So if we have a 0.25 watt resistor, that means that this will be just fine. I can pass 0.72 watts safely through the resistor without any problem. And because of that, I might add another couple LEDs in parallel with this so that the voltage is doubled. Okay, so I have a breadboard right here, 9-volt battery, and 2 jumper cables. I'm going to connect that to the positive rail and the negative rail of the breadboard. I'm going to take two pink LEDs and I'm going to stick this one in series. So this is the negative lead, so I'm going to stick the positive lead right there. And then find one of these resistors. I'm going to connect the positive lead directly to the battery. There we go. And then let's see how this works. I'm going to connect the resistor to the anode of the second LED and then connect that to cathode, and it's a nice color. And they're not heating up at all, and neither is the resistor. Alright, so I rearranged stuff a little bit so that you could see it easier. So you can see anode of this LED is connected to ground. Cathode of this LED is connected to the anode, or minus of this LED. Cathode is positive LED, so cathode of this is connected to the resistor, which is connected to positive rail on the breadboard. So I think we're going to modify this circuit a little bit. Taking our 9-volt battery with the plus and minus, and then what we're going to do is we're going to take our LEDs and then we're going to take two more LEDs, so we're going to have 4. We're going to connect them to the two like that, and connect it to the positive, and then we're going to connect it to two resistors like this, so these are connected to the negative side. We will have 4 LEDs this time. It'll be just like this circuit where 3 volts, 3 volts, 3 volts, 3 volts, and we'll have 3 volts left over to go through these resistors, except 2 LEDs that are in series, like are in here, will draw 0.024 amps. By doubling that and putting them in parallel, that'll make it draw 48 milliamps instead of 24 milliamp. Except the thing about parallel is that the voltage is not affected. So we will still have 3 volts left over going across here. That won't be affected. We don't have to double voltage for parallel, just amperage. So since this circuit is essentially the same as this, we don't have to change any resistor values. We can still use our same resistors. All we need to do is in parallel add another resistor. One thing to note about this though is that sometimes it won't work with more than like 2 different colors depending on your resistor values, because some colors draw more amperage, but usually if you have the same resistor values, then you'll be fine with what you're doing. If you're using 2 different values, then the calculations become very complicated. So we're gonna stick with same color, same current draw, and same value resistors, and we will be fine. Alright, here's the circuit I was talking about. As you can see, there are now 4 LEDs, all arranged according to this schematic. This is basically how we're going to take all of our 80 LEDs and connect them to one power source. And what I'm going to do is I'm going to add even more levels, you know. So it's going to be, instead of two lines of LEDs, it's going to be probably 4 or 5. Just to conserve space and make it easier. These resistors are each 200 ohms, so if we have the 3 extra volts that I was talking about and divide that by 200, we get the current being passed through, and that's only 15 milliamps. And these are 24. But what I was thinking was, if I put 2 of these in parallel, that would cut the resistance in half, so that it would only be 100 ohms of resistance across these instead of 200. So if we did 3 divided by 100, it's 0.03, and that's 30 milliamps. So I think that's what I'll do, even though it's a little bit more than what these LEDs are meant to take. Oh, one other thing, when you're soldering to perf board like this, some people like to go through the top where the metal contacts are. That's actually not what you're supposed to do. You're supposed to go through this is actually the top, the side with no metal contacts, and then these metal contacts are meant to be soldered to. Okay, so I stuck all of these LEDs in here. I managed to get everything except ultraviolet. So I got white, blue, orange, green, and pink, and yellow. I think these are red. These are the red ones. Hopefully I can fit resistors in between each of these rows. I left kind of little spaces. Okay, so I have everything all stuck in here, and I bent all the pins back so that they don't come out. I'm gonna take this down and solder it. Alright, here I am a couple days later with this. I had no idea how long it would take me to solder. It took me more than 2 days to do this, and if you just look at this, it's insane. Okay, here's everything plugged in. Right here are two ultraviolet LEDs, which aren't really lighting up right now because for some reason they don't like to light up when everything else is plugged in. Is really bright. Each segment, each color is individually powered so you can control each color. This was a kind of a fun project, I guess. I'm satisfied that it's done, and I'll see what else I can do with it.